Hey there and welcome back guys to another Alpha Math video. In this lesson I want to take you through a fun and interesting topic called trigonometry. We are primarily going to be focusing on the reduction and co-functions. Okay, and up here we have a question 5.1. It says simplify fully. Sine of 90 degrees minus x times cos of 180 degrees plus x plus tan x times cos x multiplied by sine x minus 180. Okay, so what's important for you to remember here is your reduction tables and also your co-functions table. What's also going to be important is to note that not all the reductions will be written as we see them here. Some might be a bit different, like swapped around. Maybe you have the unknown angle and then the minus 180. In this instance, you need to remember some other formats as well. And this is the alternate reductions table. This is not its official name, it's just the name I gave it, because this is the one that you tend to see a bit more frequently than just your regular old reduction. So it's good to know this one as well. For example, if the x and the 180 swapped around, you have x minus 180. That would be classified as this third quadrant. And since it's in the third quadrant, we know that sine is going to be negative. So that will just become negative sine x. Now, let's get back to our question at hand. Sine 90 minus x. Well, since it's a co-function, sine of 90 minus x simply becomes positive cos x. Right. And then cos of 180 plus is in the third quadrant, so cos becomes negative. Right. Tan is an identity expressed as sine divided by cos. And then tan is also being multiplied by this cos over here. So I'm just going to write that like that. But now notice this is actually quite important. Tan is sine divided by cos, and then we're multiplying by cos. Notice how, since we're dividing and then multiplying, those two operations should cancel each other out. Okay, then we have sine x minus 180, and this is going to be negative sine x, also in the third quadrant from the alternate table. Right, now let's simplify this a little bit further. So we have cos x multiplied by negative cos x, and that's going to be negative cos squared x. Right, and then we are adding that to, so we have a sign over here and then a negative sign over there. When you multiply those, we get negative sine squared x. I'm simply going to factor out a negative here to get cos squared x positive plus sine squared x. So when we're adding sine squared plus cos squared, that is simply equal to 1. And this is therefore your final answer. Okay, so all of this is simply equal to 1. Moving on to our second question. Here we have sine of 140 degrees multiplied by sine of 360 degrees minus x. Okay, that's being divided by cos of 50 degrees, I'll put that in brackets, times tan of negative x. Now let's make use of our reduction tables and simplify this even further. First of all, the sine 140 degrees, I'm going to change into sine 90 degrees plus 50 degrees. And the reason why I'm not going for a straightforward reduction of 180 minus 40 is because I noticed here that if I use 90, first of all, sine will become its co-function cos when you use 90. And we have the 50 degrees, meaning we're also going to get the same angle. Okay. Then sine 360 degrees minus x is in the fourth quadrant. And we understand that sine is negative in the fourth quadrant. Okay, at the bottom we still have the cos 50 And tan of a negative angle is also negative tan x. Right, that's the fourth quadrant. Right, to continue simplifying here, I guess first I'll change the sine to cos, because that's the co-function. Right, whenever you're dealing with 90 plus or 90 minus, sine should always change into cos, and vice versa. Cos would also change into sine if you were dealing with a 90 plus or 90 minus angle. And here you'll see that these two things are now going to cancel each other out. Okay. Then, well, the negatives should also cancel each other out. So that just leaves me with sine divided by tan. Sine x divided by tan x. I'm going to write that out in a more linear way like this. Sine x divided by tan x. And the reason I'm also doing so is because tan is a fraction in of itself. Tan is actually sine divided by cos. And so I generally don't like dividing by fractions. Instead, what I do is I multiply by the reciprocal of the fraction. So we are going to multiply by cos over sine. Reciprocal simply means to swap this around, and then make sure you also change that division sign to a multiplication sign. Here what we notice is the multiplication by sign and the division by sign would also cancel each other out like we saw earlier. And we are then left with cos x at the top. It's this one over here. And that's our final answer. Cool. All of this is simply equal to cos x. And this will be our third and last example for this video. Let's have a look at this question here. So this is 1 minus cos squared a divided by 4 cos 90 plus a. For this one, you'll have to know your Pythagorean identity. Sine squared x plus cos squared x is equal to 1. Now that x could be any angle. In this case, we are looking at a's as our angle, but I'm just going to use the x as my illustration here. Okay, if I, for example, subtract cos squared x on both sides of my equation, that would leave me with sine squared x equal to 1 minus cos squared x. So when we look at this part, this numerator here, 1 minus cos squared a, that is simply going to be equal to sine squared a because of this identity here. Okay, right, and we are being, or this thing is being divided by 4 times cos of 90 plus a. Remember, that's a reduction, or pardon me, a co-function, and it's in the second quadrant. Therefore, cos becomes negative sine a. Negative because it's in the second quadrant. Cos is negative in the second quadrant. And cos changes to sine because of the 90 degrees. Right. We can continue simplifying. In fact, you'll see here that the sign at the bottom, the denominator sign, we cancel out with one of the signs on top. Notice there's 2, so one of them is going to go away, and that actually just leaves us with sine a at the top, one of them only, and negative 4 at the bottom. This can also be written as 1 over 4, or negative a quarter, multiplied by sine a. And you can just leave your answer like this. That's good enough. The question said, if we just revise over what it asked us to do, simplify the expression into a single trigonomic term, and that's what we did.